In this video, we will discuss case 1 of special cases in Routh array. So, generally we discuss so many problems related to Routh array. So, here we are going to discuss some special case in Routh array. So, when you are forming Routh array, if you observe any one of the starting element in row as 0, then you will get problem in calculating other elements. So, that is the difficulty you are facing in Routh array. So, these special cases are nothing but difficulties you are going to face in Routh array, and solutions to solve related to that difficulties we are going to discuss here. So, first difficulty we are going to discuss here. Two types of difficulties you are going to get in forming Routh array. First difficulty is when the first term in any row is equivalent to 0, whether and rest of the elements in that row are at least non-zero element. So, when the first term in any row of the Routh array is 0, while rest of the row has at least one non-zero element. So, this is considered as first case in special cases or first difficulty. For this, the solution, we are having two types of solutions for this. So, substitute 1 by z in characteristic equation by substituting 1 by z in characteristic equation, and after getting the modified characteristic equation, reforming the Routh array and defining the stability is one solution for this problem. Another solution is just by replacing 0 with a limit summation 0 tending to sigma. So, limit summation here, this is not summation, this is sigma tending to 0, sigma we need to replace in place of 0. So, by taking simple example, you are going to understand the whole case 1. So, this is characteristic equation defining a system. Generally, to justify the stability of the system, we are going to draw the Routh array. So, generally I am going to draw the Routh array. So, like this, from maximum power of s to minimum power, I need to consider s cube, s square, s power 1, s power 0. At s power 0, constant term we need to consider. So, first two rows must be considered from characteristic equation like this, a1, a2, a3, a4, a5, a6 like this. So, the coefficients of this characteristic equation are a1, a2, a0, a1, a2, a3 like that. So, here a0 is 1 and here also 1, 2 and here also 2 and 5. So, no more elements are there, that is why just put 0 and close the Routh array. To get this element at s square row, so you need to multiply 1 into 2 minus 1 into 2 divided by 1. 1 into 2 means 2, 1 into 2 means 2, 2 minus 2, 0 divided by 1, you are going to get 0. And here to get this element, so you need to multiply 1 into 5 minus 1 into 0. 1 into 5 means 5 minus 0 divided by 1, you are going to get 5 here. And here to get this element, so you are going to get, so 1 into, there is no other cross element, so that is why you need to consider 0 here. So, now to get the element here, so 0 into 2 minus 1 into 5. So, 0 into 2 minus 1 into 5, you are getting some negative value. So, but whenever you observe the first element in this row is 0, you need to stop here and you need to treat this as difficulty and you need to form the solution to get the accurate solution. If you continue this process, you are going to get the wrong solution. You may get the wrong solution. So, 0 into 2, 0 into 2 minus 1 into 5 divided by 0 you are going to get. So, divided by 0 means you are not getting the proper solution here. So, that is why. So, here I am going to consider 1 by z in place of s. So, in my characteristic equation, in place of s, I am going to consider 1 by z whole power 4 plus 1 by z whole cube plus 2 into 1 by z whole square plus 2 into 1 by z plus 5 is equivalent to 0. Now, so you just cross multiply 5z power 4 plus 2z cube plus 2z square plus z plus 1 is equivalent to 0. This is the modified characteristic equation in terms of z. Now you can form the Routh array in terms of z. Z power 4, so z cube, z square and z power 0. Always as like this, at s power 0 position you need to consider constant term, like that way only. So here I am going to consider my constant term 1, and here first 2 rows I am going to fill with the coefficients of this characteristic equation. So that means 5, 2, 2, 1 and 1. Here I am not having any element, so put 0 and close the Routh array. So here 2 into 2 minus 5 into 1 divided by 2. So 2 into 2 is 4, 4 minus 5, 2 into 2 minus 5 divided by 2. So you are going to get minus 1 by 2, minus 1 by 2 means minus 0.5. To get the value here, so you need the combination of first combination and cross combination to this position. So that means 2 into 1 minus 5 into 0 divided by 2. So 2 into 1 is 2 minus 0 divided by 2. So that means 1 here, and here there is no cross elements, that means 0. 2 into 0, 5 into 0 means 0 divided by anything. So you are going to consider 0. So now here minus 0.5 minus 2 divided by minus 0.5. So minus 0.5 minus 2, so minus 0.5 divided minus 2 divided by minus 0.5, that means minus 2.5 divided by 0.5. So minus 2.5 divided by minus 0.5. So if you cancel 25 by 5, so 5 is 25. So the value equivalent to this is equivalent to 5 here. And now here if you consider the values here, this column with this column, so you can see these two are zeros, minus 0.5 into 0 minus 2 into 0 divided by minus 0.5. You are going to get 0 here and 0 here. And now here you are having A naught. Now this is the Routh array. So all the first column elements are non-zero now. So now you can say, so this is Routh array for the given system, and by this Routh array definitely whatever you are justifying, that is accurately correct. So that is more accurate than this. If you follow like this, in this step you are going to get infinity. Here in this case definitely you can say the stability of the system. You can see after forming Routh array, to justify the stability we need to observe the first column elements whether those are positive or not to say the system is stable. A system is said to be stable when the first column elements of Routh array must be positive. But here one of the element is negative, so we can say this system is unstable system. So this system is unstable system, and here the number of poles in the right half of S plane depends upon the number of sign changes. Here you can see, so this is positive pole and here negative is there. So here to here a sign change is there. So one pole, so pole 1, and here negative to positive another pole, pole 2. So totally 2 poles are there in the right half of S plane to make this system as unstable. So finally the system with this given characteristic equation is an unstable system, definitely. Here the number of poles in the right half of S plane to make that system unstable is 2. So now this is one solution for this difficulty, and another solution is just by replacing some sigma in place of 0, just by replacing sigma in place of 0. So, here what we got here means, here we got 0, just I am replacing sigma in place of this. So, now 2 sigma minus 1 into 5 divided by sigma, limit sigma tending to 0 we need to consider. So, now if you consider this, you are going to get minus infinity here. In this position, you are going to get minus infinity. Minus infinity means if sigma tending to 0, at that point only minus infinity. Minus infinity means again the system is unstable system. You can see 2 sigma by sigma. So, this is equivalent to 2. You can separate. I am just evaluating that limit sigma tending to 0, 2 sigma minus 5 by sigma. So, this you can write like sigma tending to 0, 2 minus 5 by sigma. So, if you given sigma is equivalent to 0, then 5 by 0 is equivalent to infinity. So, in front that is minus, so minus infinity, 2 minus infinity minus infinity. So, here you are having minus infinity at this point. So, whatever it may be, if you got minus value in the first column, then you can say the system is unstable and the number of sign changes from here to here and here to here, one minus is there. So, definitely 2 poles are there. So, this 1 by z procedure is more accurate process for this difficulty. If you want shortcut, then you just go for this substitution of sigma. So, in next problems we are going to solve different difficulties related to case 1 in different problems in the next few classes. So, there you are going to clarify some more doubts related to this process. So, special cases of Routh array, we are having 2 special cases. One of the special case is this, the 2 solutions for this special case is these 2. Substitution of sigma, substitution of 1 by z in characteristic equation. So, this is more accurate process I think, but this more shortcut process. So, whichever you want you can use that process. So, here the condition you need to apply whenever you got first term of your row, whenever first term of your row is 0 and at least you are having one non-zero element in the remaining row. So, if you observe this row, here you got 0, at least one non-zero element is there. If all the elements are 0 in a row, that will comes under second case. So, first element is 0 and at least one non-zero element in the row is there, then that will comes under first case or first special case in Routh array. So, we will solve some problems related to this, then you can clarify your doubts related to this in that videos.